All right, boys and girls, it's another lesson with me, Vizar, your network engineer and your instructor and teacher. We are going to learn about VLSM and how to correctly do it. Variable length subnet mask VLSM. Until this chapter, we have been doing subnetting using a fixed size for our blocks. So for example, we took a 192.168.1.0 class C network and divided into 4 blocks. In order to have 256, we created these blocks and we have 64 hosts for each subnet. Now, is this is this a really efficient way for creating subnets? Let's say I would have the following requirements. One subnet with 12 hosts, one subnet with 44 hosts, one subnet with 2 hosts. Point-to-point links are a good example where you only need 2 IP host addresses and one subnet for 24 hosts. I have 4 subnets, so it's no problem, but I am still wasting a lot of IP addresses. If we use the block 64 for our subnet where we only need 2 IP addresses, we will be throwing to the trash 62 IP addresses away. So now we might think why we care about this because we are using a private network address 192.168.1.0 and we have plenty of space. This is true. Try to think about this on a global scale with the internet. We don't want to throw away valuable public IP addresses. Let's say we want to subnet 192.168.1.0 network in the most efficient way. Let's take a look at the requirements I just showed you again. So we are having to do the following. Let me see. Am I sharing the correct screen? Let me just share one more time with you guys because I think I'm not even sharing. I'm just talking. I'm talking and I might not be sharing. So let me just go over again. So we were talking about a block of 256 addresses and we divided in 4 blocks, 64 hosts for each network. And we have the requirements of 12 hosts, 44, 2, and then 24. Once again, we have 12, 44, 2, and 24 hosts. Now, those are the requirements. What kind of subnets would we need to fit these hosts? Let's see. 12 hosts, the smallest is a block of 16, 44 hosts, 64, 2 hosts, 4, 24 hosts, 32. Those are the smallest block that we need in order to accomplish this goal. Now, let me clear the drawing for a moment. And let's take a look at the block. If we do the following and divide it 64, we leave this as 3, 4, 16, and 32, you have a better organization. We just saved some valuable IP addresses. Now, the next thing to do is answer the following questions. What are the network addresses? What are the broadcast addresses? What is the subnet mask? What are the usable host IP addresses? When using VLSM, start from the biggest subnet first, the largest subnet first. Otherwise, you will be overlapping. You will be having overlapping address space. You will have overlapping. It's a good idea to remember the idea of blocks because you will visualize the size of the subnets this way. So we have the following network addresses. We have the 192.168.1.0, that 1.64, that 1.96, that 1.12, and that 1.116. this is where the space starts, where the the free space starts. So what are the broadcast addresses for these networks? And let me just erase that drawing so we can continue moving forward. The broadcast addresses that we have are these. The first one is 1.63 for the first network, 1.95 for the second subnet. The third subnet is 1.111, and the fourth and last one is 1.115. Now let's continue. Because we have different subnets, we need to calculate the subnet mask for each subnet. So let's do that. The first one is the magic number 256 minus 64. I don't know if we have already seen it, but this time of the course, but if not, we will look at it and we will learn how to do it. Basically, you subtract 256 minus 64 and you get a value of 182. The subnet mask will be 255.255.255.192. We will be subtracting this, and the next one will be, the first block is 64 because it's what we subtract. Now, in order to accomplish the amount of addresses and hosts, we need to subtract 32. And we will get to 24. This 255.255.255.224. It will give us the next block, the 32. 16 is the following. We subtract 16 and we get 240. 255, 255, 255, 240. That is the next mask. And finally, minus 4, that is the last one. 255, 255, 255, 252. Those are the blocks that we will be using during this conversion for the VLSM to successfully work. Now, let me clear the drawings for a moment. And where do these numbers come from? You may be asking, where do we get these numbers? Well, these numbers actually, if you go up, we were working with them. In order to get the specific amount of addresses, it will be 12 hosts, the block of 16, 44 hosts, the block of 64, 2 hosts, the block of 4, and 24 hosts, the block of 32. That's where they come from. How do we know? For example, because if we do for this block of 4, for example, 2 to the power of 2 will give us a number 4. And that's where we need the block of 4. 2 to the power of 5 will give us 32. And that is the block 32 for covering 24 hosts. So that's basically it. Now, let me see if there is a step-by-step or something else. No, that's pretty much. If you want to know the specific IP addresses, like the one is 1.0 for the first one, then we were having 64 for the other one. Then plus 32, we get 196 for the next network. Then plus, do you guys remember? Plus 16, we get 112 for the other one, and plus 4, 116 for the other one. So we were adding here. We were adding the 64 here, the 32 here. Then we got the 16 added here, and we got the number 4. We were adding the blocks in order to complete the networks that we needed for this VLSM calculation. Okay, let me just erase this so we can move forward. Let's go, let's go, let's go. Now, you have the magic happening here. What we have here is the following. Maybe I can do a highlighting. Let me see if I can find a highlighter. Maybe I can use a green color. So we have the network, the first host, the last host, and the broadcaster. And so on. The network, the first host, the last host, and the broadcast IP address. We have then the network, the first host, the last host, and the broadcast. And the last subnet we have 112 is the network. Then we have the first usable IP address, the last usable IP address, and the broadcast. And there you go. You have in a very easy way with the VLSM and the magic number completed these four networks, and you are taking advantage of the free space. That is essential. Let me just clear the drawings. Let me just move back to the red color in case we need to write something else. Here you go. 182 and 168.1.0/24 by VLSM. Now you can do more examples. We can do the 172.16.0.0, and you can do the 34, the 50, the 31, and the 20, and the 8. And, well, what do we need to solve this problem? We need the following. We will need um, block of 512 for the first one, 250 for the other one, 64 for the 31 host. For 32, we need for 20 hosts, we will need a block of 32. And for 8, we will need a block of 16. In that way, with this information and blocks, we can do the next exercise. Now, remember that at the end of this book, in page 61, after page 61, you will have the answers to these exercises. So if you're encountering issues and you're stuck, you can go to page 61 and then look for the exercise. This one, let me see which one is it. It should have a number. I don't see it there. Well, most of the exercises are at the end of the chapter. I'm going to look for that in a minute to see if this exercise is there. Okay, let me see. Oh, this is actually the answer right now. Because of the network and broadcast addresses in block 32, you can only have 30 usable host IP addresses. That's why 64 fits in 31 hosts. And these are the subnets that we will be getting now. The first network, second network, third, and so on, fourth, fifth, and the sixth network. Okay, and then you will have the following. Let me clear the drawings. You will have the following. The broadcast for each of these networks. There you go. And that's basically it. Remember, practice makes perfect. So you have to keep on practicing VLSM to understand this. And this is the calculation for the subnets. For the first one, you have 512. So just subtract. Now, normally the 250 block would have a mask of 255.255.255.0. We combine 250 by 2 and we create the 512. Now, things changing a little bit because we are not using the magic number. We are using a block of 512, which is actually the binary conversion will be /23, which is a mask of 255.255.254.0. Starting from this point, you can do the next subnet. You are using 64. The next block is 64. So right now you can use the magic number and this one will work. For the second one, let's see what happened. 56. So it is basically the same. The subnet mask is 255.255.255.0. You're just, let's see, you're just adding a one basically. So this is the first subnet mask. This is the second subnet mask. And then you have the 192 for the other mask, the 224 for the subnet 4 network, and the 16 for the subnet 5 is at 240. So I want to validate something. I want to validate something here. Okay, the first network is 172.16.0.0. The second network is 172.16.2.0, 3.0. Then you have 3.64, 3.96, and so on. And there are more exercises. What I want to see is maybe at the bottom of the book in page 64, if these were done, if these VLSM calculations were done. So let me see, maybe in page 71. Let's look it up. Let's look it up. I see some networks here. Are they from the VLSM section that we have been working on? That's the big question. Let me just double check here. Okay, yes, this is VLSM section. This is actually page 73, where you can see the answers there. Okay, this is the one that they are giving us as homework, and they are using blocks of 32. These are the answers. There is another one with blocks of 8, and that's pretty much. Oh, these are the answers. Now, I will show you an easier way to do this VLSM later on in this course, which is with a calculator, but you have to learn both ways, um, this way and the VLSM calculator in order to be fully prepared for real life examples. Now, it's actually practice. If you can do your notebook and find it and just use your pencil, your eraser, your pen, and do these conversions by hand, it will be essential for your CCNA studies. That is one of the examples there that you have. There's so many practice about VLSM. I want to do it with the calculator, that one that we were having some trouble because it was a little bit difficult. Let me go back to page 5 so I can move to variable length subnetting. Maybe I can do that one. Okay, they give us this. Okay, maybe I can do this one. Let me see if I can do it with the calculator. Give me just a moment. Tutu. So we have the following network. What is the initial network that they give us for this second one that we were having a little bit of problems? Let me go there. It is actually, they don't give us a slash for this one. So let me just copy the network for a moment. Let me just copy the network. And it's actually like 6 networks, or how many do we have there in total? 1, 2, 3, 4, 5. We have 5, so it's 5 subnets. Okay, so we have 340, 340 for the first one. Then we have a total of 250 for the other one, 250. We have 31. We have 20. We have an 8. Let's just generate, and there you go. It's not that difficult, but you see the slash 33, 23 is actually the one that we were using. Then we have 24, 26, 27, and 28. Let's see if these matches the answers that we have there for the subnet mask. Let me see, let me see. Okay, so the first one is slash 23. We got it, right? 255.255.255.254. Then we have slash 24. There you go, 24. Then we have what else? 192. What is that one? Do you guys know? 192 is 26. 255.255.255.192 slash 26. Then we have a slash 27. It's actually the 32. And it's 255.255.255.224. And finally, we have the 240. We subtract 255 minus 16, and we get 240. So we can only use the magic number when it is 256 less than 256. But in this first one, we were not able to use the magic number because it is higher than 256. So we have to use something different. We have to use the conversion from decimal to binary. And once we did that, we were able to get the mask, which is slash 23 or 255.255, the 254, that's 0. So let me just go there for a moment. I don't have the conversion for this one, but maybe I can do it real quick to close this chapter here. So we will have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and then a 0. Okay, then we will have 0, 0, 0, 0, 0, 0, 0, 0. There you go. Now, I want to show you from this example. I need to just click on this one that we have there. Well, maybe I can just do the math there. I want to show you something here. If we count the followings, we will have 8 plus 8 is actually 16, 17, 18, 19, 20, 21, 22, 23. If we do that conversion of this one will be 255, that 255, that 254. And how do we know this is the right one and we are doing the correct one? Because 512 is 2 to the power of 9. And that is represented here. Let me use another color, maybe a blue. If we count these 8 zeros and this one, we get 9, 2 to the power of 9. And that is basically what we are doing. These ones are zeros and the other ones are ones. This conversion, following that 512 comes from when you do 2 to the power of 9, in order to get the 512 minus 2 with the formula 2 to the power of n, you get a total of 510 available host addresses per network. That's what we need to understand. We are not doing the magic number, but we are working more along the lines of digital to decimal and decimal to digital. That's basically what we are doing. So I think we have covered pretty much everything about VLSM. It was a little not clear at the beginning, but with practice, we have been able to understand better. And what happened, let's just erase the drawing. What happened later on when we have finally completed the first one, we go with the other ones. With the block with this block, the second block, do you guys remember what was it? With the block of 256, we get basically the mass is 255. So it will be the following. Let me just show you. Let me just show you there. This one will be like doing a subtraction as follows. It will be like using the magic number 256 minus 255. Oh, let me see. 256. No, it's actually 256. Let me see. We get 255. 256. We are not really using the magic number here. We are also using the decimal to binary. So it's actually the following. 2 to the power of what will cover this amount of networks. Do you guys see the pattern here? Do you guys see the pattern? We are, let's take a look at that. 256 slash 23 slash 24 is the mask that we get here, slash 24. And it's 255. So that is actually when we are having all in ones. 1, 2, 3, 4, 5, 6, 7, 8. It's 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, and then 0, 0, 0, 0, 0, 0, 0, 0. Now, it's a class C to get a total of how many addresses per network. How many do we need here? Let's just erase it for a moment. The second one, how many do we need? Um, let's go back. We needed 250 hosts. So in order to cover 250 hosts, we will need a /24. So let me go back there. /24 for 254 hosts available. That is a little bit what I am understanding is when we are doing 2 to the power of 8. Oh, that's it. 2 to the power of 8 is what we are missing here and that one. That's what I was not getting the number. They didn't tell us that. So let me do the math now. Let me use the red one. 2 to the power 8 will be all of these in zeros. So when we were having the ones, all the ones, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 0, 0, 0, 0, 0, 0, 0, 0. This is what happened. Let me use another color, maybe a green one. Okay, 2 to the power of 8 will give us 256 hosts per network. And these are the zeros that we have here. Now, we're getting the 250 hosts per network. We're fine. But this is the mask with all ones, and all ones that we need, which is 255.255.255.0. And that's the correct way to do it. We are basically doing 2 to the power of 8 minus 2. Once we get this, we get a total of 254 available host IP addresses per network. That is a little bit difficult because we have to combine binary and decimal to binary. But after these networks, we can finally use the magic number. And there is where the magics come from. It's actually very easy. The magic comes now because you only have to do the following. You have to do this subtraction. The magic number plus 64 will give us a 192, and this is the next subnet mask. Let's clear the drawings. Moving forward, the magic number minus 32 will give us the mask of that 224. Magic number minus 16 will give us the mask of that 240. Now, I have shared with you in other lessons a table which is very essential and important for these processes. I think actually it was like lesson 5 or 6 is a magic table which is very useful. I think it was lesson 4. And let me just look it up. Give me just a moment. It's in lesson 4. It is actually in the IPv4 subnetting section. I shared this material with you. This magic table will save your life, basically, because it will give you the amount of hosts per networks in seconds. And basically for the exam, you have to memorize from, let's say, from this one to this one, something like this. You have to memorize basically the different mask, like from 128 to 254. And you have having that memorized and doing practice and practice and practice, you will be doing this in seconds. It will be easier for you. You will become a master. And that's basically it. If we have, for example, this is another table. This is another table for higher networks where you have, for example, eight 8,192 hosts, 32,768 hosts, 4096 hosts, 496 hosts, 1,024 hosts, and this is the correct mask for those specific network. There is the mask length, the famous slash. You have the slash 24, 25, 26, 27, 28. Those are like the most essential ones to learn for the exams. But learning these calculations and practicing, you will be able to create these tables in from the top of your mind, and it will be easier to follow. It will be very easy to follow. So I think we have pretty much covered everything for the lesson. It was a little bit of difficult to plug everything together, all the knowledge and understanding, but I think we have pretty much covered everything about VLSM. There is another class only focused on how to do calculations in the VLSM calculator. I will be sharing that with you as well. For the time being, my name is Cesar. It's been a pleasure working with you today, learning about VLSM and how to apply it in real life and some scenarios. Remember, you have the book. This book is called Mastering Subnetting, How to Master Subnetting. If I'm not mistaken, let me just double check. How to do, how to master subnetting binary. So please use the book, practice and practice and practice. Do your own exercises in order to become an expert in subnetting. In this case, we were doing VLSM. So let me just clear the drawings here. We should be almost finished with the lesson. Boys and girls, it's been a pleasure. My name is Cesar. I will see you at the top of success. Take care, and until next time, goodbye.